Alright, onward to the second page. Number 12. All real numbers that are greater than 5 or less than or equal to 1. So all my x values to be greater than 5, or they could also be less than or equal to negative 1. There we go. That's that one. So greater than 5 is okay. Less than or equal to negative 1, also good. All real numbers that are greater than or equal to negative 2.5 and less than 3.5. Now, this is how many of you will do this. You'll say x greater than or equal to negative 2.5 and less than 3. What's going on here? Now, you're writing as you're reading, which is good most of the time. But you need to read the statement, take a step back, and then decide, how am I going to attack this? So we know that 2.5 negative is our low end. We need to be greater than or equal to negative 2.5. Notice it's just a subtle order adjustment. And then we also want it to be less than 3.5. So negative 2.5 is going to be right here. And then 3.5 is going to be right there. Very subtle adjustment, but that order becomes important when it comes to figuring out how you want to write this. The sum of 3x plus 1 is greater than negative 5 and less than or equal to 10. Notice again, read this part first. We want to be bigger than negative 5 and less than or equal to 10. Reading it first and then slapping the numbers down second allows you to make that adjustment should it be necessary. So negative 6 is less than 3x, which is less than or equal to 9. Divide the 3 off. I'm going to get negative 2 is less than x, which is less than or equal to 3. Again, throw my numbers up on the number line. There we go. Alright, number 15. Solve and graph. So I add the 8 to both sides. And I'm going to get a 1 is less than x is less than 10. Again, this is just the answer. We're ready to go right here. So I've got a 1, I've got a 10, I've got open circles at both, and draw a line. Next page. Next problem. It's an or, so either one can be true. I've got 3x is less than 6, divide by 3, divide by 3. So x can be less than 2, or, and again, I'm just going to move this out of here. So I've got negative x is less than negative 5. I'm going to divide by negative 1. I'm going to get x is greater than positive 5. Now when I look at this, x can be bigger than 5, or x can be less than 2. Either one is fine. Here's 2. Less than 2 is okay. Here's 5. Bigger than 5 is okay. Last one. Divide by 5. X is less than negative 6. Or, pull the 10. X is greater than negative 3. So I get my numbers. Negative 3, negative 6. Bigger than negative 3 is okay. Smaller than negative 6 is okay. Both are good. Ands and ors. Be careful. Be careful. Let's go to that next page and see how much we can do this page too. So, 18. $30 for membership fee to the ice skating rink. And then $5 each time you go. We want this to be equal to 7 times for non-members. They're lame. They won't pay the membership. That's okay though. We're going to pull that 5x over. 30 is equal to 2x. Divide the 2 off. And 15 visits will be our answer. Next page. Or next problem rather. I'm just 2 answers. Alright. We want the revenues so that our profit is more than or equal to $250. Well, if our profit is $250, this is revenues minus expenses. So we have to clear $155 before we start making money. So we need to add that $155 to our profits. We need to take in $405 or more. Let's be fancy here. Let's go more than $405. Not 405 plus. Better. All right. Manufacturing tolerances. This is one that I get a lot of questions about in class. Because Marak, what's it saying? I have no idea. I'm just plain freaking out about it. So we need to think about what they're trying to tell us. When you machine something, or when you build something, you want it to be this big. Let's call that a chain link. Well, sometimes that chain link is just a touch bigger, slight exaggeration. And sometimes that chain link is just a touch small, slight exaggeration. We want it to be this size, but we know there will be some errors, both big and small. So 0.3 minus that difference is the smallest it can be. That's a minus sign. And 0.3 bigger than that, with 4 zeros of course, is the biggest it can be. A little bit smaller is okay. A little bit bigger is okay. So we're going to write that out. 0.2, 3 nines, and a 7. That's the smallest we can get. And 0.3, 3 zeros, and a 3 is as big as we can get. Going to number 21. We are ordering discount movie tickets. Yay, discount movie tickets. And they're $7 each. So $7 each ticket. We have to pay a shipping fee of $4. We want to spend no more than $40 total. So subtract the 4. 7x is less than or equal to 36. Divide by 7. And you're going to get x is less than or equal to 5 point whatever. The point whatever is not important because we can't buy more than 5. 5 is our maximum number. We're going to leave off that decimal place.